Okay, so it looks like your mistake came from when you made you wrote down your subject to, your constraint. So what I did, I wrote your original problem as 15.4, number 5. The original thing that we're trying to minimize, we're trying to get the minimum of this, which was f of x, y equals xy. Then subject to, and there's your constraint. Now, you have to solve it so it's equal to 0, and either which way would be fine. You could either subtract the y over, or you could add the other stuff, or subtract the other stuff over. It looks like, so to me it looks like you subtracted the y, which should have resulted in a negative x squared, and you can see you have a positive. So now, because your work's a little blurry, I'm not going to try to work off of it and find the other mistakes because it's giving me a headache. So I'm just going to redo the problem and let you find the difference. And that may have just been it. Just that negative right there may have been it. So here we go. So the first thing you did, and it looked like you did it correctly, was take the partial derivatives. Or actually, first you write your Lagrange. It's asking to be done using Lagrange. So you write your Lagrange function. And then you take your partial derivatives with respect to x, with respect to y, and with respect to lambda. So from there, we set each of them equal to 0, and start to solve. So now, the question here is quite simple. We say, what method do I want to use to solve this? Well, I can't just pop them in my graphing calculator and do root expression on form using matrices because it's not linear. So the next easiest way would probably be substitution method. So I always recommend solve for a lambda. Find the lambda that's easiest to solve for. So I personally think that one right there is the easiest. So I'm going to solve for lambda equals x. So now, everywhere I have a lambda, I'm going to go and place that into my other equations and replace it with x. So that means this equation would become 0 equals y minus 2x squared. So now I have two equations. I have one right here, which would be the variables are only x and y, and then I have another one over here where the variables are only, again, x and y, which makes my life pretty easy. So now I have two equations, two unknowns. So solve one of the equations for one of the variables. Pick whichever one's easiest. I'll solve this first one over here on the left because it's very easy to solve for y. I just have y equals 2x squared. So now, using the logic of substitution as before, just everywhere I have y in the other equation, sub in 2x squared. So that gives me 0 equals negative x squared minus 2x squared plus 3. And now we're ready to start solving. So that gives me negative 3x squared plus 3. So I subtract over. Negative 3 equals negative 3x squared. Divide through. So that gives me x squared equals 1. So now I take the square root of both sides. So that gives me x equals plus or minus 1. So now I have to not lose sight of the big picture. I have to say, why am I doing this? Well, it's because I'm trying to find a ordered pair, or actually in this case an ordered triplet, because my original function's in 3D, two independent variables, one dependent variable. So I have to use my x's to find my y. So let's go back and find some equation where we know y equals. Well, that'd be right here, right? So I'm going to plug both values in and see what values I get for y. So when I use a x equals 1 and I substitute that in, I end up getting y equals 2. And then similarly, when I substitute in x equals negative 1, I'll end up getting out y equals 2 because it's squared. So now I use these values, substitute them back into my original equation to find my z value, to find my output value. So all the way back up to the beginning, it was x times y. Okay, so the function I'm subbing into is f of x y equals x y. So now when I put these numbers in, I end up getting 2 and I end up getting negative 2. So I have two answers to this system. I have 1, 2, 2, and I have negative 1, 2, negative 2. And we have to keep in mind it wants us to find the minimum from this equation. So which z value is lower? It would be this one right there, because it has a z value of negative 2. So therefore, my answer would be I have a minimum of negative 2 at negative 1, 2. Okay, I hope that makes sense.